First off, it's helpful to define what is a function. A function is anything that, what we say, passes the vertical line test. Vertical line meaning we can throw a vertical line anywhere on the graph and it only hits the function once. So you can imagine drawing lots of little vertical lines there. We're only going to touch the function once. What that means is that for each x value, there is only one y value. And you could imagine in your head that a regular quadratic would fit this as well. For each x value, there's just one y value. Each x is just one y. The reverse isn't true. A y value might have two x values. So here, a y value of 3 could have two x values. But we still say it's a function simply because it passes the vertical line test. Something that doesn't pass the vertical line test is what we call a relation. So you can imagine putting a vertical line through there and it touching twice. We would say it's not a function, it's a relation. And it only needs to fail the line test once for that to be true. So, what we work with in methods is almost always functions. It won't be until year 12 that you'll really start doing some calculus, perhaps with relations. Alright, so these here are also examples of relations. If we shade in a whole quadrant, that clearly fails a vertical line test. Or here, I'm told it's a relation, so we can probably find a pair of points that are directly above each other. Or there, there. If you can find a pair that fail a vertical line test, we've called it a relation. So, the fact that's captioned there tells me that they fail. Normally we'll make a fail nice and easy if we ask it in a test. Alright, so what about a non-graphical explanation? Which of the following map functions? Now remember, a function means each x only has one y. So here, each of these x's only has one y. So tick, it's a function. Each x only has one y. Yes, no. Yes, no. So imagine these points. That point, 4, -1, and 4, 3, will be 2 points vertically above each other if you're going to plot them on the graph. So that would be a relation. Here, 1 to 1, 1, 1, 1, 1, 1, 1, 1, 1. Yes, that's a function. Even though this is used twice, each x still only has one y. So this would pass the vertical line test, even though it's not a diagram, but you have to sort of visualize each pair of points. Right. I know they're not on your notes, but does that sort of make some sense? How we can apply the one and only one rule for each x? Alright, I'm running on anyway. Alright, so notation. So, we call this f of x, and it behaves a lot like y. So, they are functionally the same thing. Often you'll see graphs labelled x on the x-axis, f of x on the y-axis. You'll have this f of x heading up. And there's something neat that we can do with it. What the brackets mean is we are substituting a value in. So this we would pronounce f of 0, and here f of 0 is saying we're going to remove x and put 0 in where x is. So in our case here, f of 0, and you can write this underneath, f of 0 would look like 3 lots of 0 minus 0 squared plus 2. So we would say that f of 0 equals 2. And if we wanted to put this on a graph, and we're not going to put it on a graph, what that implies is that this is the x value, and this is either the f of x value or the y value. Meaning this 0 going in, 2 coming out, gives you a point of 0, 2 on a graph. So we're going to work between algebra and graphs quite often. Subbing in, x is 0, you'll get out a point. Similarly here, let's look at f of 3. F of 3 means we're pulling out the x and substituting in 3. Oh, there's a 2. Oh, there's 2. implies 3 across, 2 up is on the graph. Now, f of minus 3. Careful as always when substituting in negative things, brackets will help. So that's 3 lots of neg 3 minus neg 3 squared plus 2. What's that? Minus 9, minus
Minus 20.
nearly.
Minus 18.
I think the plus 2 trips us up there. I reckon these two get you to minus 18 and then plus 2, so I'm thinking minus 16.
Yeah, that's all right.
Yeah.
So why is it a negative 3 before the f negative 3?
So we were asked to sub in negative 3.
Oh, that's the next one.
Oh, sorry, yeah. This one's
Yeah.
the positive 3, that's the next one, yeah.
Yeah.
So basically, whatever's in this brackets gets substituted in place of x. Now that seems really nice and easy when we're putting numbers in, because we're quite used to subbing numbers in. However, we accelerate quite quickly, if you guys turn your page over, to subbing mini functions in. Can I erase what's on the board? So, same rules apply as before. Whatever's in the brackets gets substituted into the function. So here, we are replacing this x with x plus 4. Meaning, in this case here, f of x plus 4 is equal to 2 bracket x plus 4 squared plus 3 lots of x plus 4 minus 1. Now, it asks in simplest form. So who's confident with expanding and simplifying?
I'll leave something behind.
Yeah, I'll leave something behind it. Give it a shot now, and then in a second I'll come back and finish it and we'll see if we end up at the same place. Do yell out if I've done something wrong. If you didn't end where I ended, is it possible you went this?
Yes.
Alright, every time you guys do that, what is it, second hero? Like someone kills a kid. Draw to your mind, they are not the same. Not at all. It's really tempting and it's a really common error to make. But this is really x plus 4 squared, is it happening twice? And then use FOIL first. Outers, inners, lasts. If you do this shortcut, you miss that apex in the middle and you'll get it wrong. So be very careful when squaring out of brackets. If you're not confident, do it shorthand, just write them next to each other and use FOIL to expand them out. Nothing wrong with that. Alright. If you're pretty comfy with this, I'm just going to do the next 3 on the board, and can you guys do the next 3 as well? Same deal with each of them, we're substituting it into the function above. It is a lot of effort, but it'll make you quick. Why is that one saying?
Oh no, I just got my number wrong. I'll go for 3 minutes.
Oh my God, so tough. Oh, have we already done B? I get 16.
So there's a concept of play here called cognitive overload. Basically, cognitive overload is the idea that you're trying to hold too much stuff in your head. The reason we write things out in maths is so we don't have to hold it in your head. So I'm not expecting any of you to go from this top line to the bottom line in one. Put in working lines. Even in between here and here, if you need to put in another line to make sure you get that expansion right, go for it. You shouldn't be trying to, for example, I'm not confident with my mental arithmetic to do this and throw the 2 in at the same time. I'd mess something up. So I've left the 2 there, done it, and then put the 2 in on the next line. So you've just got to be nice to yourself and write things down so you're not trying to do too much in your head. Okay. That is, I think, all you need to make a shot at the questions. So some work time. Last week I didn't give you a huge amount of time to finish the questions. So make a start on wherever you got up to last time. And then today we're going 3A, 3B. We have a double lesson tomorrow morning. So we will start tomorrow by giving you a little more work time on this before we go on to the compound functions. Alright, sound good?
Yep.
Go for it. I'll stop recording.